right. We are looking at simplifying expressions, which is a little bit different than solving expressions. We're not actually going to be solving any equations. It's a little bit different than simplifying, or excuse me, than evaluating expressions. Evaluating is when you got it down to one number. So simplifying is trying to make the problem, well, simpler by using a couple different properties, the commutative, the associative, and the distributive properties. Many of these you've seen before, many of them you've used before, you just haven't really thought too much about them. And we're going to get into a little more depth with this. We still won't be solving any equations, but we're going to be simplifying some different expressions. So here they are, or there's two of them anyways, the commutative property and the associative property. We've talked about them in class a couple times, and I know that you talked about them in class in 6th grade, but the commutative property allows you to flip-flop what's going on. The examples that they give are 2 plus 7 is the same as 7 plus 2. 3 times 9 is the same as 9 times 3. And so the commutative property allows you to flip the order in which those numbers occur. Now be careful. This only works with addition and multiplication. It does not work with subtraction. You cannot say that 2 minus 7 is the same as 7 minus 2. 2 minus 7 would give you negative 5. 7 minus 2 would give you 5. Those are not equal. And so the commutative property does not work with multiplication, or excuse me, with subtraction, and does not work with division. Associative property. The associative property is when you are associating things together. If you have associates, they are people that are your friends, that you communicate with, that you work with. And so your associates are the people that you are in contact with. And the associative property is like grouping. Again, you'll notice with the examples they give, 6 plus 8 plus 2, you can either group it 6 plus 8 as a group, and then plus 2. So 6 and 8 are associated together. You could also group it 8 plus 2 as a group, and that's the associative property. And you can group those numbers, you can regroup those numbers with addition and multiplication. And that's the associative property. We're going to use these, and we're going to look at how that's effective. Where the book is asking you to be more specific with some of these properties is with some mental math. Now, we're going to look at these. This is stuff that we're trying to train your brain to do. If we just follow PEMDAS, we don't use these the commutative property at all. We don't use the associative property. We just follow PEMDAS. We would do 1/3 times 5 and get 5/3, and do 5/3 times 33 and get a number from there. But if we can remember these properties, if we can rearrange this, and by rearrange I mean let's use the commutative property, and instead of having it 1/3 times 5 times 33, let's switch 33 and 5. We're going to use that, or that commutative property, and we're going to go 1/3 times 33 times 5. And you might think, well, who cares? You're still getting the same result. And that's true. However, 1/3 times 33, if you remember that a fraction is just division, 1/3 is the same as dividing by 3. It's 1 divided by 3. So instead of 1/3 times 33, really this is asking what's 33 divided by 3. And you can see that if you made 33 into a fraction, you would multiply, and you would get 33 over 3, which 33 divided by 3, 33/3, is 11. And so with some mental math, we can see that if we flip-flop 33 and 5, if we use that commutative property to flip those around, 1/3 of 33, a third of 30, if you break 33 into thirds, if you break it into 3 parts, you're going to get 11. And 11 times 5 is a lot easier to do in your head than 1/3 times 5. So 11 times 5, 55. Let's do another one. That might have been a little bit confusing. So let's look at another one here. So you want to write this down. So pause it, write this down. I'm assuming you wrote it down. And so looking at this problem, we've got 15 and 1/3 plus 4 plus 1 2/3. And if we just went from left to right, 15 and 1/3 plus 4, we'd have to get some common denominators. We'd have to work all this stuff out. It'd be easier to use that commutative property to flip these around. So I'm going to rewrite it. I'm going to have you do the same. 15 and 1/3 plus 1 and 2/3 plus 4. Now, a couple things we notice. They already have common denominators, thirds. So I'm not counting the 4 right now. But the 15 and 1/3 and the 1 and 2/3, they have common denominators. We're adding. And so when we're looking, we've got 15 and we've got 1. And we've got 1/3 and we've got 2/3. So 15 and 1/3 plus 1 and 2/3, that's going to give me, well, 16 and 3/3. But 3/3 is 1. 16 and 3/3, that's going to give me 17. So 17 plus 4. So see how the 15 and 1/3 and the 1 and 2/3, they combined really well together. Just like the 1/3 and the 33, they combined really well together. That worked out nice into a nice clean number. So rather than doing 15 and 1/3 plus 4 and getting another fraction, we did 15 and 1/3 plus 1 and 2/3 and got a nice clean number of 17. And then when we add those together, our answer is 21. And we're trying to train you or train your brains to think in this way, where you're looking at all three options and thinking, okay, can I rearrange this to make it easier on myself? Can I rearrange those numbers so that things work out cleaner and work out nicer, and I can do it in my head? And that's what we're trying to practice. And so that's how really we want to be using these properties, is with some more mental math. And so that's what we're looking at here. And it's going to take some practice to get used to this commutative property and associative property. We're also going to look at how to write some of these steps down, but we'll get to that in a separate video. The distributive property. Okay, distributive property is a third property that we have. The distributive property is the most used. Commutative and the associative we'll use a little bit, but really the distributive property we will use a lot. A lot, a ton, a lot. We will use the distributive property a lot. The distributive property allows us to distribute a number through the parentheses. If I had $100 and I wanted to distribute that amongst you, I would have to divide it amongst all. I have to give each of you the same amount. So I'd have to take my $100 and I have to give everybody in the class some money. I have to give everybody the same amount. So the distributive property of the numbers says if we have a problem like this, where we have parentheses, we have two numbers inside, or more than two numbers, but we'll start with 2, I'm going to take that 3, and I'm going to do, well, when we have, let me even back up here, if we had 3 parentheses 4, that's 3 times 4. That's going to give me 12. If I had 3 parentheses 8, that's 3 times 8, and that's going to give me 24. So the parentheses means multiplication. And with this distributive property, with a problem similar to this, the parentheses still means multiplication, except we're going to do it twice. As the arrows show, we're going to do 3 times 4, and we're going to do 3 times 8. We're going to do that twice. 3 times 4, 12, and 3 times 8, 24. And so the final answer then is going to be 36. And you might be wondering, well, why didn't we just do the parentheses first? 4 plus 8 is 12 times 3 is 36. And with numbers, if they're all numbers, then yeah, sure, that would be easier, and we would definitely do it that way. Where we are going to end up using this more is when we have a variable inside those parentheses. So instead of 3 parentheses 4 plus 8, we might have an expression that says 3 parentheses y plus 8. And then we have to deal with that y. We have to get that y out of the parentheses. So we're going to use this distributive property to allow us to rewrite things and get different results, or different way of wording it, different way of rearranging those numbers. And that's going to help us a lot in future problems. And so this distributive property, we distribute through the parentheses and we multiply the number on the outside times every number separately on the inside. So if it was 3 parentheses 4 plus 8 minus 12 plus, 5. okay, we would distribute. And I know some of you are thinking, why wouldn't I just do the numbers on the inside of the parentheses first? We're practicing this property. So it'd be 12 plus 24 minus 36 plus 15, which would give us 15 in the end. And so that distributive property applies here, and we're going to use this in this class. You can use it in 8th grade, you can use it in 9th grade, you can use it in 10th grade. You're going to use it up through calculus. This distributive property is a very powerful property. I've just spent, 5 minutes on this one property alone. It's very important. Okay. What your book is going to ask you to do and what your assignments are going to ask you to do is going to be a little bit, it's going to feel like a worthless exercise. And I get that, but there is some meaning behind it, and I'll try and explain that a little bit. You're just going to have to trust me, though, and say, okay, I'll do this. It's going to ask you to write the product using the distributive property. It's not going to want you to find the answer. It doesn't want you to evaluate 9 times 52 and get a number. That's not what they want. What we want you to do is think about this in a mental math sort of way. How to do 9 times 52 without writing it down. And what that's going to break down to is 9 times 50 plus 2. The reason we would do this is because 9 times 50 is easier to do in your head than 9 times 52. 9 times 5 is 45, so 9 times 50 is 450. 9 times 2 is easy to do in your head, that's 18. Well, we can just add those together and get 468. That's a lot easier than, and you can do that in your head, rather than writing it out as 52 times 9. Well, really, let's look at this. When you write it out 52 times 9, you're doing the exact same thing. You're doing 9 times 2 is 18. And that carrying the one thing, you're adding 1 to the tens place. 9 times 5 is 45. That's the 45 that we get. I'm going to put this little 5 there. That's that 45 that we get from 49 times 5. But really, that's 450. That 5 is in the tens place. And we add the 1 from the 18 to get that 468. So when you multiply, you are doing the distributive property. You're just writing it out in a very different way. So 8 times 33. 8 times 33 might be difficult to do in your head unless you think about it as 8 times 30 plus 3. 8 times 30, 240. 8 times 3, 24. So 264. That's a little bit easier to do in your head. And so the distributive property, what they're looking for in this section might seem pointless, because I can do 8 times 33 without doing the distributive property. However, we're trying to train your brain to break things apart. We've got 33. How can we break that into parts? Putting things together is a lot easier than taking them apart correctly. And that might seem, might not seem true. You know, it's easy to just take a TV and throw it on the ground and break it. But to break it apart in a very specific way, and say, how can I take 52 and break it into its parts? It's harder to do that than it is to simply add 50 plus 2. And we're trying to train your brain to think in a certain way. And so that's what they're going to ask you to do with these distributive properties. So when it says write the product using the distributive property, then simplify, what they mean is take that number in the parentheses and break it into 2 smaller parts, tens place and ones place. And then multiply, and you can do that mentally and add them together. And that's what we're looking for. Okay, we're going to move on a little bit here. So that, again, those are the different properties, and it's really mostly about mental math. Okay, so we're going to identify. We're going to be looking at simplifying expressions a little bit further. We've got 4x minus 3x plus 2 here. Now, what we're going to be looking at are combining some like terms. We're going to combine the terms that are alike. So the 4x, the 4x, the 3x, and the 2, not all of them are alike. The 4x and the 3x, they both have x's. The 2 does not. And so we call those like terms. I would like you to write that down. The one that's over here we have is what's called a constant. It doesn't have an x, so it's a constant. Once we have our like terms, we're going to combine using what are called coefficients. And we have mentioned these before. The coefficient is the number that comes before the variable. So 1x squared plus 3x, we actually can't combine those together because they don't have the same term. The x squared and the x are different. Since the x squared and the x are different, we're kind of stuck. We can't say what 1x squared is plus 3x. It's like saying 1 orange plus 3 apples. How many apples do you have? 3. We can't combine it with the orange. However, if we have 4 apples, or 4 x-ray machines, I suppose, and 3 x-ray machines, 4 x-ray machines minus 3 x-ray machines, 1 x-ray machine. And then we still have this plus 2, I don't know, doctors. So we've got this constant over here, 1x plus 2. So we're combining some like terms, and we're making the problem simpler. We're simplifying the expression. A couple examples. So simplify the expression. Simplify. We're not solving it. We will not figure out what p is. We cannot figure out what p is. We cannot figure out what x is. We're going to simplify it, though, and try and combine like terms to make it a simpler problem. 72p minus 52, or 25p. They both have a like term. They both have a p there, and they have a coefficient. So we're going to combine those coefficients together. We're going to get 72p minus 25p, and we're going to get, I don't know, something. What are we going to get? 48, is that right? Let me double check myself here, because again, end of the day, my brain is not always working the way it should. And so if I subtract, nope, see, I was wrong, 47. 47, and the p. The p doesn't go anywhere. Where's the p? And that sounds really kind of funny almost, but the p hasn't gone anywhere. We still have these p's. 72 minus 25, we've got 72 p's minus 25 p's. We have 47 p's left over. The next one, we've got 3/4 x to the 4th plus x to the 4th. Now, we have these common terms, these like terms, but they don't both have coefficients. I have a coefficient here, but none there. We do have a coefficient, even if it's not written. There's always a 1 there. There's 1 x to the 4th. I can see it. It's right there. I see it. It's x to the 4th. I can see 1 x to the 4th. So even if there's no coefficient written, there is a coefficient. It's 3/4 x to the 4th plus x to the 4th. So 3/4 x to the 4th plus 1 x to the 4th. We've got 3/4 plus 1. I can rewrite 1 as 4/4, which 3/4 plus 4/4. Now I have a common denominator. I get 7/4, which I can simplify to 1 3/4. So I've got 1 3/4 x to the 4th power. And that's my simplified version. Rather than having two different variable or two different terms, I've got 1. So 47p, 1 3/4 x to the 4th. Try this one on your own, and then we'll do it. Okay, 0.5m plus 2.5n. I'm stuck. There's two different variables. There's nothing I can do with this. And so you can either say cannot combine. You might see something like that on a quiz, cannot combine. You could also, on a test, just rewrite it, because it is as simplified as it can get. We can't simplify it anymore. So you might see either that, or you might see cannot combine. Cannot combine. And you'll have to forgive my sloppy handwriting. Okay, here's the last three, I believe. Go ahead and give these three a try. Simplify by combining the like terms. All right, so we got 16 p's. Oh, that line here, I should mention, just means that it's not 3c.3m squared. That line means that these are our three different problems, 3a, 3b, and 3c. 16p plus 84p, we have a common term, p and p, and if we add those together, we're going to get 100 p's. Negative 20t minus 8.5t squared, we don't have a common term. T and t squared are different. That's your different terms, and so we can't do that. So you can either write cannot combine, or you can simply rewrite the problem because it is as simplified as it can get. The last one, we've got 3m squared plus m cubed. Again, different terms. M squared, m cubed, nothing I can do. So it's as simplified as it gets. And we will look at the next stuff in a different video.